Hi, good morning everyone. Today we'll be looking at a Tombolic workshop. So I did this workshop on 2nd January to create a Damascus knife. This is a fantastic facility where they have all the equipments, the forging required for doing it. So the first step is looking at getting it trained on how do you move the metal. When the metal is hot, how do you move just using a hydraulic press. It was an 80-ton hydraulic press, and the instructor was telling me in terms of looking at how you need to move step by step to get a best option. What you do is to take the billets. So it was a 10 layered billet that we started off with, so where we are heating that entire billets up, and what we do is we go and press this across. Initially it will be a gentle press so that the material can stick to each other. So then what you do is you rotate it and you make sure that you are pressing it properly from both the sides so that you get a uniform distribution of the metal. So the initial press will be a gentle press to make sure the metal layers are binding with each other. This is a hard steel with a combination of a soft steel in between, so that makes the 5 layers of hard steel and 5 layers of soft steel. So you put it in the clean once again. Then what you do is you take the metal, and what we want to do in the next step is to elongate this, make sure the whole of the layers are bound properly to each other. So in this step what we are going to do, we are making sure that the layers are binding to each other. So what you can see is you can see that there is a little bit more pressure that is applied here more than the first step that we did, and the distribution happens across all the 4 different layers. But the aim is to make sure that all the different layers are merging with each other, and it's creating a homogeneous layer of material. So now once it is done, so we will be looking at the next steps to go forward. So now this is done. So what we'll do is we'll put it inside the kiln once again to heat it up. So you can only work in a metal at a certain temperature. So also the orientation is important, how you're putting inside the kiln. Now we take out again metal from the kiln. So it's about 7 to 8 minutes for each of these passes to go through. So this is what we are doing is the first pass. In the first pass, it is making sure the material is homogeneously integrated with each other, and all the layers are mixed properly, and it is binding to each other, and this creates a billet. So basically it's a mix of material with the different layers so much with each other. So at this time what we want to do is we want to elongate it a little bit more, so that we have a longer billet that can be taken to the next step once the whole process of material being done. The material is all homogeneously done. So then what we do is we go to the next step where we want to cut it exactly to half and fold the material on top of each other, doubling the layer. So we do the layers for about 3 times repetition, so totally forming about the first layer when you multiply it becomes 20 layers, and the next step when you divide or cut and form, that becomes 40 layers, and finally the third step you will achieve about 80 layers. So there are other forgers where they go in multiples of these layers. In terms of the number of billets that you use and the number of layers that you use, you can really achieve more complexity. So what we are going to do is we are going to mark exactly to the center. The billet was about 16 centimeters, so we are marking it at around 8 centimeters. So we create a marking so that we can go for the next step where we are going to cut this material into half. So we go there like 75% depth, and then what we do is we are going to rotate that material and take it back. So just let's look at this process. And now once you do is you need to just put it back, and now it's a process where you are going to cut that material. So you're going to use like it's a metal knife. basically what you're going to do is, it's using a hydraulic press. We are going to make a deep indent cut to about 75%, and once the material is cut for about 75%, you take this material and then basically you clean that surface first. And once you clean the surface, so you saw the surface and you make sure the entire surface is really clean, because it's going to fold onto each other. You need to make sure there are no plugs or any other material available. Then you also apply a generous amount of soda ash after this process. This is what we're going to do now. We're going to apply soda ash. So the soda ash is going to make sure that the binding is correct and that the impurities are all removed off. So once that step is done, so what we are going to do now is to bend it over, fold across each other. So you need to make sure that it is perfectly horizontal to the surface, and then we are going to fold the material on top of each other. So once this is done, this step is done, okay, make sure it's uniform across all the different directions. So once this is done, the billet is ready for the next step. So we have folded once, so now the layers have 20 layers. So now it's the same process continues. We are going to draw that 20 layers and make sure it is homogeneous, all the layers are mixed with each other. So it's taking. So one of the advantages of Damascus steel is it is a soft layer combined with a hard layer. So hard steel provides the hardness to make sure the sharp shell surfaces remain sharp, and soft material make sure that it's having a life. So again, adding a little bit of flux material here to make sure it's homogenized and none of the air gaps are existing. So once that is done, we'll again put it back into the thing. Now it is ready for the next step. So what we are going to do now, we are going to draw this further and make it a little bit longer. So the process repeats for about 3 times. If you want a little bit more different Damascus pattern, you can increase the number of layers. So if you do this process for about 7 times, you will be getting 1280 layers of steel over each other. And if you double that to about 8 times, it will become 2500 layers. So that's like ultimate. So it requires a lot of time and a lot of patience. So the workshop was only for 1 day, so we have limited ourselves to about 3 layers in this session. So what you can see is now the material is ready. It is elongated properly, so and it's mixed thoroughly. So now it has achieved the result. I'm just going to speed up the process here. It's the same process. What we are going to do is to elongate and make sure the material is mixed homogeneously. And once this is done, we'll follow the same steps as what we have done before. You're just going to mark the center and then look at cutting this entire material into half for about 75% and folding it once again. This is going to be the final fold that we are going to do. And again, as you can see, it's the same process that happens again and again. It's a repetitive process, but it's essential for you to make sure that these steps are followed properly to get a homogeneous mix of the material. And the most important thing, you need to make sure your material is always centered and all the layers are properly pressed or hot pressed in the proper way to make sure the material is uniform across the top and the bottom. Otherwise you'll end up having a larger material at one side and a smaller material at the other side. The other important element that you need to make sure is the neck that you're holding. That should be really firm and it should be held properly. So what we will do at this stage is we will go to the next step of elongating that material. So now we have achieved the 3 layers homogeneous. So we are using this special tool to press it and elongate or thin the material further. So what this particular jig is going to do is to take the material, it presses it very hard, and once you have pressed it hard, you just have to turn it around and make sure that the material is uniform. So the material is very hot. It's almost at the very close to the melting temperature of iron here. So again, we are going to further enhance further increase. The aim is that we started off with like a 10 millimeter. It was close to around 10 millimeters, and now we want to reduce that to as thin as possible, so that we can go to the next step, where what we are going to do is to heat it up once again, and then we'll cut off the half portion. We are not going to use the entire material there. We are just going to use half of that to make our material. So this much amount of material is required for us to do that, but half of it is sufficient for us to make a knife. So half of that drawn properly should give us a good chef's knife. So what we are doing today is a Gyuto knife, Japanese style. I like Japanese style because it's more balanced, lighter and easier to handle than the European style, which is slightly heavier, and it also depends on your cutting styles. I like to do a chopping motion, top to bottom, rather than a rocking motion, so that Japanese style is best for me. So as you're seeing here, we are using the two sides of the die. So one to thin the material up. So this is the side that is going to thin the material. So make sure that the material is thinned out. The other side that we use just to flatten that material out. So the next side that you see, what we are going to do is to make this as thin as possible. So we want to get to about 5 mm at this stage, about 5 to 6 mm in the thickness, as well as the width is very important. You need to make sure the width is done. So now we have achieved it. We have cut the component into the required billet size. So now we will go to our next stage of straightening this up. So we are going to elongate it a little bit more and make sure that it's there. So you can see already. So the material is going to be elongated. It is super hot at this time. So it's always important that you maintain the safety protocols at all the time. I'm wearing goggles. So I have a hard toe shoe as well as with a fire resistant glove that's helping me to protect. Even then there are splinters that's going to splash over and it's going to burn parts of your skin, and that's part and parcel of any metal work that you're going to do. So what we are doing is we are trying to make sure, elongate it and make sure that we can get this to a desired shape, and the next steps that we can continue by putting that into a hand forging. So we'll again heat it up. The moment the material becomes cold, it is non-workable. It's very difficult to be a hit on a hard steel and get any shape from it. So what we'll do is we'll take this out. It's important how you hold it, and the tongs are made specifically for holding the billet of this particular size. And that's one of the main reasons that we are also bringing that billet to the particular size so that we can have uniform. So now we are measuring this to be close to around 17 or 18 centimeters at this time, and that's going to help us to achieve a 20 centimeter knife. So it's very important that you measure it also. The width has to be perfect. When you hammer it later on in the later parts of the stages, so you'll utilize the entire material to get this width done. Okay, so now we move to the next step. So what we are going to do is to elongate, make it flatten. So you can see we already cut out the neck, and we are starting to get the shape of a knife. So what we are going to do now, so we are going to get it into a conical shape. It's not going to be the final shape of the knife, but it is very close to how the knife is going to look like. So what we're going to do is we will use the material and use that across. So one is you need to also look at the shaft as well as the cutting edge. You need to know which side that you're going, and you need to consistently hammer, and that I kept missing it continuously was getting this billet shape. The top side that you see is going to be where you are going to sharpen it, and that is where your impact has to happen. Bottom side is where your shank is going to come. It's very important that you keep a good shank for the integrity of the material. I did slight, I think since this was the first time that I was doing, I was not very careful in terms of my shaft. I hit it quite hard and I tagged this. So what we're going to do is we are going to get a rough cut for about 60 degrees. This is how the Gyuto knife is angled at. So this cut is going to help us to achieve what we want to get as a final shape of the knife. I was a little bit skeptical at this time. I was looking at the whole billet and said, okay, how is it going to become a knife? Since this was the first time, I'm just going through this entire process, doing this forging. It was quite interesting to learn the whole process. It was quite difficult to hold the hammer at the right instance. I made a couple of mistakes. Learned it the hard way that you should not be moving your hammer when you are working. Now you can see we are getting a closer shape to the knife. Now what we need to do is you need to elongate it and make sure the hot portions are there. Again, the mistake that I'm doing is, if you can see, my impact is not uniform. I'm just moving my hammer around and I'm keeping my hammer at 90 degrees. So usually when you have working towards the bend, you should always angle it towards the material. So that is, you are going slightly above 90 degrees at about 120 degrees to get that angular blow, and you need to work only on one area at a time to get the shape properly. So usually what happens whenever you are hammering on one side, the material tends to bend. So you need to make sure the material is always straight, so that way you can see that we are flattening out as and when we are moving across. So roughly we have about 5 to 6 mm thickness of the material here. Our goal is to get it to about 3 mm. So that's an ideal state for us to get that across, and it all happens through hard hammering and the proper traditional forging method. So that's why these are called as the hand forged knife. So these are not shaped across, so you can start seeing that we are getting a very nice corner, and we are also building the material across. So I learned it very fast to look at how I can work on one particular region and start moving up or start moving down. So this is what was important, and it takes a little bit of time to do it. Like it's the first time, it takes a longer time to get the steps correctly done. So if you are doing it a second or third time, I think you will become better. So if you look at it, so I was just not hammering it in the right way. That's what the instructor is telling me, that I need to make sure that I'm hammering it in the right direction to get the proper shape. So that's exactly what I did after that, and then you can see that the whole hammering actually helps to get the narrow to the material, and I'm just making this straight as much as possible. So once we have pretty much the shape of the billet and the corner of the knife that is ready, so what we are going to do is now the next step will be to looking at enlarging it or working on a center particular zone. So we start from the center. So we start reducing the thickness and getting the edge properly. One mistake that you can see is I'm trying to do here is I'm holding the knife at the wrong side. You should always hold the edge section towards the outside and start working it from the bottom to top, and then you are going to reduce the thickness at the bottom and keep the thickness at the top intact. And this is where it's very crucial that you get your hammering technique right. You are applying the right amount of pressure as well as the way you're holding and hammering it across. Please make sure that you're also aware that there are a lot of splinters that are going around, and these splinters are quite hot. It can burn up your skin. So if you're not very confident to At this stage you can also use a safety glove, but I had done metal work before and then was confident that I can manage this portion. So now again you can see the shape is changed, so I need to just bring that back to the proper shape. So now I straighten this up. So once I straighten this up, I just put it back into the oven, and you cannot work on a cold cold metal, so you need to always look at. So you can start looking at the center. The material is already started to form. Yeah, so what I'm going to do is I'm just going to put it back into the oven and then start working closely. So the center portion is always the most challenging one. So where you need to get it right, and then you need to get that across. So you can see that center portion is almost forming. I'm achieving that across. But the mistake I was doing was I was always aiming at the 90 degrees and not edging, going towards the edge with an angular momentum, and that's what created a little bit of a challenge for me when I was looking at the shape. So I was every time that you do, you need to just look at making sure that you are using the right side of the hammer, and then I straighten this out, and once I straighten it up, and I'll put it back again and start shaping it. Okay, the pretty much at the center you can see the bulge. So now what we have done is we have already completed the portion. I skipped it a little bit. I worked on the entire thing, so you can see the portions at the bottom is quite easier to achieve. So it started to look very somewhat similar to a knife. So I was not very sure even at this time that my knife is looking properly as a knife. So what I started to do is I had to work on the material to get as much thickness as possible for my base of the knife. That's what is the most important element, and it helps you to create a nice bevel and cut. And so you can see I'm trying to reduce the material as much as possible. At the same time, you can see that I was not very particular clear with my hammering, and I have damaged my shank in couple of dimensions. It still remains in my final life. When I look at the knife at the final stage, I still have some damages across, and it's difficult for me to look at it. So once it's all done, so the instructor helped me to give a finishing final touch across. So you need to have a consistent blow. You can see the way that he is hammering. He's having more than 10 years experience in doing this knife, as well as for in terms of forging. So he's a very experienced person, Nigel from Tumbinek. So a huge thanks to him for coaching and guiding me and taking me through the entire process. So you can start seeing the knife is taking a shape at this point of time, but it's still not straight. It needs a couple of more adjustments to make sure it achieves its final dimension. So what we do is everything is all done by hand. So you are looking at creating it in hand, and then you're reducing this across, so you're getting a good shape of the knife. And once it's all done, so you can also go and flatten it out, and then again make sure that the shank is straight as well as the cutting edge is straight. That's very important. The most important element is the sharpening of the knife. The angle that you take, it should be like a $1 or $1 gap between the sharpener and your knife. So we have done pretty much with the process. So we did an acid etching. So very quick time thing to see whether the patterns are formed or not formed. So once it's done, so we also use the sodium bicarbonate water just to neutralize all the impact of the acids. And then once it's done, you take a 1500 grit sandpaper and sand out. There are a lot of black material that gets formed, and you can see the pattern. So the pattern was visible only for a couple of minutes because we only did for about 5 minutes of etching. Then what I had to do is I had to clean this entire blade up, and make sure there is no rust, there is no black color material that is sticking to it, and move to the next process. So we have done a hard grit, that's around 40 grit to get this angle. Getting that bevel is very important for the knife. So that bevel determines how sharp your knife is going to be and how it's going to do. And also you need to get it's slightly like a inward bend. I tend to sharpen it more towards the right hand side, because I'm a right-handed cutter, so I need my right hand to be more precise than to the left. So I did ask the instructor to provide me the information on how I can make it more suitable for a right-handed person. So you can look at it. I tried to maintain the patina at the top, the forgings across. I wanted to get a little bit of a pattern, but I think that's going to be my next experiment. Yeah, how I can create a pattern for this knife. So pretty much the knife is done at this stage. So what we will do next is to go and polish it a little bit more, remove all the rust, and then you put a handle. So now we don't have a handle for this, so we are going to clean this all up. So now we are going to insert a handle. So what we are going to do is we are going to heat up the shank. The shank is already prepared using the hydraulic press that we were using before, and once the shank is all heated up, then you insert a wooden metal into the hot handle, and that creates the bond naturally. And then you apply a slide glue on the top to make sure your openings are covered, and you just make sure that there is no gap that is left out, so that the water or moisture does not enter inside and create a challenge at a later stage. So now it's almost done. So now they are going to insert the handle, and it's quite smoky. You can see all the wood handles that are come, and the Japanese handles are really nice to handle. It's like an 8-sided. It's an octagonal, slightly octagonal shape, and it's really nice and comfortable to hold it in the hand. One challenge I had was I made my knife slightly longer than 20 centimeter, so which created a challenge for me. You can see the branding there, CDS. It stands for my name, my wife's name, and my daughter's name, and you can see the Damascus pattern. I had to soak the knife overnight in vinegar, as well as looking at my entire thing. That was my entire collection of knife. Thank you for watching.